Hello, welcome back to Spring Damper Part 2. Uh, we'll be starting off this project by actually replacing our sprinklers. Go ahead and delete this one, and then we're going to come up and we're going to go to forces, and we will create an applied force. I want this to be two body force, and then I want it to have a K and C constant, and of course these K and C constants are going to be the same as our previous. Okay. So now it will ask us for an action body. It's not appearing down there, but I want to click on where it highlights part 2. Click on that, and then it'll ask us for a reaction body, which I want to be the ground, an action point, which I want to be the center of mass of part 2, and then it will ask for a reaction point. I would recommend doing this anywhere in the global y-axis. Is also what this recommends. It does say that you can snap to a point using the working grid. I'm not too sure if that is working for me, but I'll just go ahead and click there. And then we can see it does appear to be only in the Y direction. So it does seem to have worked for us. Okay, so next we'll want to actually go ahead and simulate the model, make sure that this does work. I'll go ahead and, well, actually, first I want to measure by going to here, measure. I actually want to see what I want to measure first. So these are things that I will be finding in my results after I run the simulation here. So this first one will be the spring force. So I will change the measure name to spring underscore force. Of course, it's going to be a force. And then we want to do mass times acceleration due to gravity. And then, of course, I want to keep that as part 2. And then I will hit OK. We'll now get this graph here, which is awesome. But I'm not done yet. So I want to go ahead and measure the displacement. So we'll go ahead and measure displacement. We'll call this spring displacement. And then I also want to measure this with mass due to acceleration times acceleration due to gravity. Okay, and then hit OK here. All right, so now we got our 2 boxes pulled up. Now we will actually go and run a scripted simulation. And then we'll want to go ahead and change this to an interactive one. We'll want to change our end time to 2 and keep our steps at 50. We can then go ahead and click start. And as we can see, we're going to start getting numbers in both our displacement, our force over time, and our displacement over time. And then we'll go ahead and move on to step 3. We'll then want to create a length versus force plot. So I'm going to go ahead and actually right click on my spring force one. We'll go to transfer to full plot. All right. And then from this one, we're actually going to want to clear all of our data. So we'll just hit clear plot. And then I want to select what my independent axis data is. And I'll just hit that. And then this will pull up. We'll then want to set this to our spring length. Which in this case is my measurement 2. That is because of the way that the plots are. And I know that this one is different. We'll then select our Q as our component. And then we'll click OK. Under this, you'll want to then hit Add Curves. But first, we'll want to hit our result and our component here. Okay, so correction, we're actually going to want to select our spring force, hit Q, and then add curves. And as we can see, we're now getting it on this one. All right, and then we'll hit our spring force 1, Q, add curves. And you should get something very similar to this. All right. So if you've made it this far, we will now head to finding our static equilibrium of the single component action-reaction force. To view the static equilibrium, we'll go ahead and we'll minimize this. And then we're actually going to want to go back to our simulation control. We'll then, of course, click our handy-dandy static equilibrium tool. It'll tell us the operation is complete. And if you got it in your force box that it's 1836, which is the same as we previously got, you probably got it right. So that will conclude part 2 of the spring damper.